let us study an AC circuit containing only a capacitor. Okay, so we have a circuit like this way. Okay. This was the AC voltage, and this is a capacitor here. Okay. This is AC voltage here V, and this is a capacitor, that is C here. Okay, C we can write also, we know it. Okay, but we'll write here. C is a capacitor. Okay, now let's see what's the applied voltage at VU. Okay, so the applied voltage, okay, that is V is equal to, we get here Vm sine omega t. This is small v, this is capital Vm. Okay, that is remember. Now we know that the capacitance formula. Okay, so we know that the capacitance, that is C is equal to Q by V. Okay, this is a formula for the capacitance. Again, this V also is capital V. Okay, you must now find what is V here. Okay, so cross multiply interchange here. So what we get here is V is equal to Q by C. Okay, this is on cross multiplication. Okay, now what we do is we apply this one Kirchhoff's loop rule here. Okay, so apply Kirchhoff's loop rule. You can see starting is nearly similar to the all the derivations. Okay, applying Kirchhoff's loop this one loop rule. Okay, loop rule here. Then let's see what we get now. Okay, so small v plus this capital V is equal to 0. Okay, small v is this one, and this capital V is the voltage across the capacitor, that will be equal to 0. Okay, so substitute the values in C now. Okay, so substitute the values, okay, of small v and capital V. Small v is what, that is Vm sine omega t, plus capital V is what, that is Q by C. Okay, so in this case actually what happens is we must write here minus, okay, Q by C. Okay, why minus is this gives plus, okay, voltage, and this will absorb the voltage, so write here minus sign, and that's equal to 0. So take this minus Q by C to the right side here, it will become plus. Okay, so what we get is Vm sine omega t is equal to Q by C, plus Q by C. Okay, now we must see what is Q only, so cross multiply the C upwards here. Okay, so what you get here is C into Vm sine omega t is equal to Q. Rearrange. Okay, on rearranging, what happens is Q will go this side now. So Q is equal to C into Vm, okay, sine omega t. Okay, V is not proper right here. Okay, Vm sine omega t. Okay, so now next step we'll see, that is we must see what's the formula for current here. Okay, let me rub out all this and then we'll go for the next equations here. And before that also, we will note down this equation as 1. Okay, we'll use it later. Okay, I kept this equation here. Okay, now let's see what's the formula for current here. Okay, so we know that current, okay, we know that current, it means what, the flow of charges per unit time. Okay, that is I is equal to dq by dt. Okay, so now we got Q now. Substitute the value of Q here. Okay, so substitute the value of Q. Okay, so Q we got, that is d by dt of, instead of Q what we get, C into Vm sine omega t. Okay, let me take the chalk here. Sine omega t we get here. Okay, now we must differentiate this. Let me rub this out. Okay, so while differentiating, we must take out the constants now. So C is a constant, capacitance is a constant, this maximum value of voltage, that's a constant, so take it out. Okay, so what you get is C into the maximum voltage, okay, that also comes out, into d by dt of the sine omega t. Okay, now when you differentiate sine theta, what you get cos theta. Okay, so we get C into Vm, okay, into cos omega t. But next we see this omega t is also there now. So what you do, you differentiate this omega t also. Okay, so let me write in the left side here. Okay, d by dt of this omega t. Okay, so what happens, first you differentiate cosine theta, then you must differentiate this omega t also. So when differentiate this, omega is a constant now. So take omega out. So omega into dt by dt. Dt by dt we know it's 1. Okay. So you're left with omega. So that's how the omega comes here. Okay. Now this omega right front here. This side right. Okay. So get your c into Vm into omega into cos omega t. Okay. It's now clear. Now next what happens is we'll have to take the c and omega down. Okay. Let me show it you. Let me rub out this. Okay. It is this. So c and omega we must take it down. Okay, let's see how to do that. We take the below the numerator. This denominator we will take. Okay, so Vm by and c and omega we must bring down. So that is what happens is when you bring it down, it will become reciprocal now. Okay, so you'll get us 1 by c. Okay, so it will 1 by c omega. Okay, I think it's now clear. Okay, c omega you bring it down, it will become 1 by omega c. Okay, if you take this up, what happens? C omega will go up also. Okay, it's like a fraction now. Okay, show it to you. See how this 1 by c into omega. Okay, if you take the c omega, it will go up here. Okay, it's very clear now. And then we are left with what happens is we get here omega is left with outside. Okay, sorry, omega will go outside down. Okay, and then we also get cos omega t. Okay, so cos theta. Okay, so what is cos theta is equal to sine 90 plus theta. Okay, so we know that cos theta is equal to sine of 90 plus theta. Okay, this formula I'm going to use here. So instead of writing cos omega t, what you write is sine 90 plus theta. That is sine omega t plus theta. Okay, so cos omega t we write as sine of, it's 90 we get here pi by 2. Okay, sine 90 is pi by 2 plus this theta is, instead of theta we write as omega into t. Okay, so this is how we get this. Now we're going to substitute here and we can rearrange also. Okay, so rearrange cos omega t is equal to sine of, okay, this omega t plus pi by 2. Okay, so what happens? I just rearrange it here. Okay, now substitute the value of cos omega t here. Okay, substitute the value of cos omega t. Okay, in this equation. So what you get is Vm by 1 divided by c omega. Okay, inserting cos omega t, what do you write? Sine of this omega t plus pi by 2. Okay, so this is the value you will get. Okay, and left side what you get? You get here current here. Okay, because that current was an I. Okay, so you want to find the current only. Now let me erase all this, leaving this last equation here. We'll continue on the left side. Okay, so what happens is I have taken this equation here. Okay, I will erase all this. I'm going to take the equation. Instead of this equation, write as I is equal to, we get here Im into sine of this omega t plus pi by 2. Okay, so now what happens is omega t, sorry, Im is equal to this Vm by I in 1 by c omega. Okay, so where this Im is equal to Vm by 1 divided by c omega. Okay, it's very clear. So this is the equation that we need now. Okay, this is the equation for the current here. This equation we write as equation number 2. Okay, equation 1 we got now. Okay, what is equation 1? That was V is equal to Vm, okay, sine omega t. Okay, this was equation 1. Okay, we just for remembering and writing this side. Okay, so we can see that from equations 1 and 2, okay, what we see that, see this is equation 1, okay, omega t, sine omega t, see this is the angle here, okay, but here omega t plus pi by 2 is now. Okay, so we can say the current leads the voltage by pi by 2, current is more by pi by 2, okay, starts before itself. So we can say that current leads voltage, okay, by pi by 2, but that's by 90 degrees. Okay, so this we know from this equations here. Okay, this is just for remembering. Okay, so this you need not write. Already written this. Okay, you just need to write only this side. Okay, let me erase this things. Okay, next we'll see what is a phasor diagram for this. Okay, okay, let us now see the phasor diagram for this topic here. So I have drawn this two graphs also. Left side is a phasor and right side will have the waveform. Okay, so let's see the waveform for the applied AC voltage. So this will be the waveform for the applied voltage V. Okay, on this side you have V and current I. Okay, and this side what happens, you get here omega t, that is the angle. So this will be starting 0, this is pi by 2, or sorry pi, okay, pi means 180, and this is 2 pi here. Okay, it's 360. So let us now see how to draw the phasor for this. Okay, so what you do is you choose any point here, say this point, put dotted lines like this way. Okay, and then you draw the phasor here. This will be the voltage phasor here. Okay, V. And then next we will see current phasor here. Okay, so current phasor, what happens is you draw current here, current voltage. Okay, you see current starts before itself, the same. Current starts by pi by 2. Okay, so it's like this way. It starts before itself. Okay, you see the current has started before. Okay, so for that what to do is, to show it's before, I put dotted lines here. Okay, so if you see this distance here, from here to here, okay, that distance will be pi by 2. Okay, so current is starting before the voltage. So we see current leads the voltage by pi by 2. So for current, what happens is, we can choose any point here. So let me choose a point this side. Okay, and then you put dotted lines here. Okay, current is leading it by pi by 2. So current starts before, so it's not straight. Okay, so current starts here itself. Okay, so this will be for the current I. So see that now current and voltage, the difference is 90 degrees here. Okay, so current is leading the voltage by 90 degrees. Okay, so current starts before itself. Again, now you see the amplitudes here. Okay, so amplitude for the current will be, this will be I is equal to Im sine omega t plus pi by 2. In the book they have written vertically, I have written horizontally here. Okay, and then this for voltage, the amplitude for the voltage, that will be V is equal to Vm sine omega t. Okay, so this is for the phasor here. Now let us see some more terms in this. Okay, and like the last time, we write here this is O and this is A and this is B. Okay, similarly only. So we can say that OA is equal to the maximum voltage here, Vm, and then OB is equal to the maximum current Im. Okay, so this is about the phasor diagram. Okay, next we'll see what is the capacitive reactance.